The first thing I'm asking you to do is review from the very first lesson in this unit is to solve that system by graphing. So you will need a Cartesian plane. So you will need axes on here. And you can go ahead and solve that. You do not need me to show you how to do that. You can go ahead. And of course, all of you should be able to tell me the solution once you have graphed it. If you saw it up there, you know it already. If you didn't see it up there, you're graphing it right now and you're about to tell me the solution. When you have the solution, please tell me. I'm a little, what's the word I'm looking for? No, because usually when you say you're flabbergasted, it's because something you didn't expect happened and it was good. I'm not surprised at how long I am waiting for somebody to say two numbers here. I said I wanted the answer, and I'm still waiting for it, and all you had to do is graph two lines. Yes! 3 and -4. Well done. The answer is, of course, 3, -4, which, of course, was checked by subbing them back in here and finding that to be the right answer. Yeah? Yeah. Now listen to me and listen to me carefully. Do the next three things by yourself. So you pick a number, you multiply it, you solve it for y. Do not look at your neighbors, do not look at mine. There is a reason I am doing this. Everybody have a number in their head? Any random number. It does not matter. Go. Yes, it cannot be 1 or -1. Doofus. Go. When you have done those 3 steps, answer the question, what do you notice? In your own words.
One of those days?
As June progresses, one of those days becomes another day.
Most of those days.
Most of those days.
To be fair, I mean...
Because for some strange reason, we lopped on, or continue to espouse the need to have 2-month breaks in the school year so we can bring in the harvest.
Yeah.
I know I have to get my wheat in from the back 40. Oh, I don't, because I live in a house with a yard.
Well...
Nor do I need my 20 children to help me bring in the harvest. But because that 2-month break looms in front of everyone, everyone turns off their brain approximately Victoria Day.
It's even worse among the grads.
Yes.
It's going to be even worse after tomorrow.
Yes. If they did a smart thing with school, because none of you could handle 50 weeks of school, you would melt your brains and gave you shorter breaks all year long, everything would be better. But I am nothing but a small town math teacher.
Yeah, considering they take off 2 months, they could just do four weekdays.
6 weeks
Or 4
on,
days.
2 weeks off, all year round. End of discussion. It's the same amount of instructional days with no longer than a 2-week gap.
It's kind of weird that they're making us graduate before we even know if we've actually graduated, though.
Alrighty, who would like to tell me what they noticed if they did it right? What happened when you multiplied the second equation? It looked different. Then you solved for y. How did it look? The same. I chose the number 3. So I multiplied everything by 3 and got 15 minus 9 equals 81. Then I solved for y, and I ended up with the exact same equation. So what did I notice? I got the same thing. Which should tell us something, shouldn't it? What does it tell us? Results in a new equation that graphs the same. And we have seen this before in math class, haven't we? How do I add one? How do I add 1/2 and 1/3? I know, right, Bryce? 30 people. How do I add 1/2 and 1/3? Right, I have to make the denominators the same, which is 6. So it is 3/6 plus 2/6. Right? Is 3/6 the same as 1/2? Yeah. How did I get to 3/6? I multiplied. So multiplying everything by the same number keeps the same value, correct? So multiplying everything in an equation by the same number keeps the same value. Does everybody understand that concept? What if I multiplied it by a fraction? Would it still solve out to the same equation? Yes. What if I multiplied it by a decimal? Yes. What if I multiplied it by a negative? Yes. It would still graph the same. Does everybody understand that? That is what I'm saying. You can multiply an equation by any number and you will get the same line. Everybody good? Even though the equation looks different. Yeah? Yeah. Excellent. Turn the page over. Now we're going to do something that looks weird to you. We are going to add two equations together. But you have done this before when you have collected like terms, so it is not too strange. What happens when I add 4x's and 5x's? I get 9x's. What happens when I add positive 3y's and negative 3y's? I get 0y's. And what happens when I add 0 and 27? I get 27. Yeah? Excellent. Would we ever write this in math class? No. What would we write? 9x equals 27. Correct? Would I ever graph that? No, because it can be simplified. How would I simplify that? I would divide everything by 9, and x would equal what? 3. So now x is 3. X is always 3. So what does that mean the line will look like? It will go through 3 on which axis? The x-axis. And when we go back upstairs here, which I will do in a moment, to our graph, and I add that line x equals 3, lo and behold, what did it do? It went right through the same solution, didn't it? And it gave me the value x equals 3. And you notice that was the first part of our solution. Why did that happen? We'll talk about that in a moment. First, we have to talk about what happens. Two things happened when I added these equations. What is one of the things that happened? How? What happened that made this? I added them together. So the first thing is I got one equation instead of two. What else happened? What's the second thing that happened? Look at the original two equations. Look at the new equation. What happened? Before I got an answer for x, something happened. There you go. One variable was eliminated. Yeah? Everyone agree? And now we're going to do the same thing, but this time we're going to subtract. What is 4 minus 5? Negative x. What is 3 minus 3? Positive 6y. And what is 0 minus 27? Negative 27. Right? Now, what do you think, because we're not actually going to graph it, what do you think will happen if I put this new light blue line on the graph? We're not going to do it because time is a factor here. But if we were going to do it, what do you think would happen? It would intersect with all the other lines. So if we graphed it, we would find it went through 3, negative 4. So what is the point that we have learned here? We already know that multiplying it doesn't change it. And now we know that if we add or subtract them, we can do two things. We can get down to one equation, or we can eliminate one of our variables. Two things are happening here. So adding or subtracting two linear equations results in either one, a new equation, which still leads to our solution, which is what happened right here. The arrow will show up in a moment. He waited patiently. Right? And the second thing that happened was we can eliminate a variable so we can solve. And that is what happened up there. Does everybody see everything that is happening? Now notice I haven't shown you how that helps us yet. But everybody sees what is happening to these equations as we manipulate them, yes? Okay. So now let's apply that situation. See if you can take the three things we just talked about and write a third equation that will have the exact same solution as this set. Notice I'm not asking you for a solution. I'm asking you to give me a third equation that we could write here that would have the same solution. And I've given you 3 tools to find that. Everybody try. Look at your notes. Think, how can you write a third equation that will give you the same answer? And then when you think you have it, I will give 2 gummy bears to the first person that puts their hand up with a right answer.
Oh, come on.
Interesting, hey? Holloways, you may both go. It's a race.
4x plus y equals
You just let him start? You're aware of the concept of a race, yes? Okay. So what was your answer? 4x plus y equals 19. Go get 2 gummy bears. Now you can go. 2x plus 3y equals 17. You may go get 2 gummy bears. Lena, you can have 2 gummy bears for being awake this long in class.
What do you mean? I'm awake.
Lena, give me another one.
2x negative 2y equals 2.
Absolutely correct. Anybody else want a gummy bear?
I just want a gummy bear.
Then give me a right answer.
They took my answers.
There's an infinite amount of answers. Give me another one.
3x minus 3y equals 3?
Yep.
Wait, what? Oh, yeah.
Yep.
So it doesn't make me random?
Yep. Which is more proof, once again, that you guys aren't learning concepts. You're learning how to do stuff. It doesn't matter what you multiply either equation by, it's going to have the same solution. I never said that. Oh, wait a minute. Yeah, I did. Right there. You never wrote it down. Oh, wait a minute. Yeah, you did. Right there. Oh, you'll never hear it again. Oh, wait a minute. Yeah, you will, because it's going to be on the internet forever.
Are you okay?
I'm great. Now, let's actually do this thing. I'm going to use 3 different colors like I did yesterday to show you how this works. Just like I did yesterday, read those 3 steps. Do not do a thing. Just read them and make sure you understand mathematically what is being asked of you. Do all of those words make sense? No, they make dollars. Do all of those words make sense? Well, they make me sense. Are we good? Does all of that make sense? All right. So, using our blue, light blue, let's have a look at this situation. Do we see an opportunity to get rid of one variable?
Yes.
Which variable will disappear? Y. Why will Y disappear?
Because it's the same number in different signs.
Same number and different signs. So if I add these equations, what will I get? 7x equals 14. Does everybody see what has happened there?
Yes.
I have 3 x's and I have added 4 x's. I have negative 5 y's and I have added positive 5 y's. I have negative 9 and I have added 23. Does everyone understand? Can everybody do step 1? Should you write yourself a little hint here? What would that hint be? How do you decide which letter to get rid of? Hint, hint, Eric just told you. Same number, different signs. Then it's super easy. Yes? Did you just Mr. Myers me? Oh, I thought you did. I apologize. Carry on about your business. Huh? I am talking to Liam. I thought he said Mr. Myers. So then I asked him if he said Mr. Myers. And he said no. Now, in purple, it says solve for the remaining variable. What does it mean to solve for a variable? Isolate that variable. What, in this case, is our remaining variable? X. So we must isolate x. How, pray tell, do we isolate x? We divide both sides by 7, and x will equal 2. Yeah? Now that x equals 2, I will use light green and put 2 where? Wherever I see an x. Can I put it anywhere I see an x? Yes. Would I be allowed to do this? 3 times 2 minus 5y equals negative 9. Would I be allowed to do this? 4 times 2 plus 5y equals 23. Yes. And what would happen if I do one of these? I will get a value for y, won't I? What will happen if I do the other one? I will get, what will that value be? The exact same. Because this is 6 minus 5y equals negative 9. And then that is negative 5y equals negative 15 and y equals 3. Yes? And then 8 plus 5y equals 23. 5y equals 15 and y equals 3. What then is our ordered pair? 2, 3. Do I check? Of course I check. Will you check? No. You will hand me in a test with a bunch of mistakes on it, even though every single question allows you to check the answer. What you will do is write your test. 20 minutes left over. You will start talking to each other. You will hand in your test, and you will get maybe 75%. You'll be like, yeah. And then I will say, you know, you had 20 extra minutes that you could have checked each answer, because in the time I have taken to give you this little lecture, you could have checked this answer about 15 times.
Yeah, you could.
3 times 2 is 6. 5 times 3 is 15. 6 minus 15 is negative 9. Correct. 4 times 2 is 8. 5 times 3 is 15. 8 plus 15 is 23. Correct.
Mr. Myers, you're a genius.
No, I am not.
So,
Oh.
I understand when people say this way is the easier way out of the two. I understand now. Makes sense.
But if I started with this, you would all be mad. Yes.
they're both equally easy.
I know they're both equally easy because they're essentially the same thing, aren't they? Solve for a variable, substitute.
I like this way better.
All right, now, what is wrong with this one if we try to follow the steps you just followed? They will not cancel each other out, will they? Well, that's a bit of a poser. What will we do? We will multiply, just like it says right there. Why can we multiply? Because then you will have the exact same line, but it will look different, and that will allow you to cancel them out. Which one should we multiply? Equation 1 or 2? 1. What should we multiply equation 1 by? 2. When I multiply equation 1 by 2, I get a new equation. 2x minus 4y equals 14. Now, will these two play nicely? How? If I add them together, they will work wonderfully, won't they? What is 3 plus 2? 5x. 4 minus 4? 0. 1 plus 14? 15. What then does x equal? X equals 3. What can I then do with 3? Plug it in where? Every single x. I am going to put it right there because there is only one x there. Finish the loop. 3 minus 2y equals 7. Negative 2y equals 4. Y equals negative 2. What is my ordered pair? 3, negative 2. What should my last step be?
Double check your work.
Double check your work so you don't hand something in that is wrong.
So, Mr. Myers,
Yes.
when you go back to substitute checking the thing,
Uh-huh.
substitute to the original equation, not the one you multiplied.
Doesn't matter.
Because I multiplied it by the 2x, so then it would be 2 bracket 3.
Okay, so 2 times x would be 6,
Yes, so I got
right?
6 minus 4.
And negative 4 times negative 2 would be positive 8. And 6 plus 8 is 14. Well, y equals negative 2. Right here when we put the x in there. 3 minus 2y equals 7. Bring the 3 over. 7 minus 3 is 4. 4 divided by negative 2 is negative 2.
Mind blown.
Now, is 3, negative 2 times negative 2 is positive 4. Is 3 plus 4 7? Yeah. 3 times 3 is 9. Yeah. What's 4 times negative 2? Negative 8. Is 9 minus 8 1? So did we do it right? Excellently done. Now, I want to show you another little trick. What is happening here?
We can't do what we want to do.
Can't get them. So somebody's got to multiply, right? Which one? Both of them. What number should we be shooting for?
You should be going for 6.
I should be going for 6, right? Because 3 and 2 will make 6. Could I also go to 22? Why?
Yeah.
Oh, it's 11.
Because 11 and 2 would work with 22. Would it matter which one I did?
No.
Absolutely not. So let's do the easier one though, shall we? Let's get our y's to 6. What would I have to multiply this guy by to get 6? 2. So what would it become? equals what? 40. And what would I have to multiply the second one by? 3. And what would that get me? 33x plus 6y equals negative 3. Then what would I do with those? Add them up to get what? 4 and 33 is 37x. The y's disappear. 40 minus 3? 37. So what does x equal? 1. Where can I put 1? Everywhere that I see an x. 2 times 1 minus 3y equals 20. 2 minus 3y equals 20. Minus 3y equals 18. Y equals negative 6. What is my ordered pair? 1, negative 6. And we check. We already know it's going to work in the first one because that's the one we just did, right? Do I need to check all of them? We just did that one. So we'll check this one. What's 11 times 1? 11. What's 2 times negative 6? What's 11 minus 12?
1.
So are we right? You're darn tootin'. Is everybody good?
Yes.
Now, stop for a moment because some weird stuff can happen here. Okay? I'm going to give you guys... Is everybody fairly comfortable? Fairly? Okay, I want to do a couple of things that will make your life easier, but you don't need to do them. For example, what if I gave you this? Just give me a moment to think. And look at that. And I want you to solve it by elimination. What do you see that immediately makes you go, I can fix that, Eric? You see the 2's, but they're not the different signs. So what can you do instead? You could multiply by negative 1 or divide by negative 1 or subtract. Everybody with me? All those 3 things would work. You could multiply either one of them by negative 1, you could divide either one of them by negative 1, or you could subtract. If you subtracted, it would be negative 2x. 2 minus 2 is 0, right? And 8 minus 12 would be negative 4. Everybody cool? You could do that. Everybody good? All right. What if I changed it to this scenario? Could we multiply again by 1 or by negative 1? Could we divide again by negative 1? Could we subtract? Yeah, we can still subtract, but here's where the mistake can happen. If I am subtracting, 3 minus 5 is what? Negative 2x. What's negative 2 minus negative 2? 0. Negative, negative. That traps you guys. Okay? Remember, your goal is to eliminate, right? So if you end up without eliminating something, you forgot that a double negative or something like that. Everybody cool? Everybody good? All right, now let me give you one more. 3x plus y equals 7. And 2x plus, no, I don't want to do 2. 6x plus 3y Okay, everybody see this one? Okay, now watch. This is something that will help you next year. Notice something about that equation. What do you notice? They're all divisible by 3. So I'm going to change this guy to 2x plus y equals 6. You cool? Everybody cool with that? Now watch. Y equals negative 3x plus 7, correct? Everyone agree? The brown one is the same as the yellow one, yes? Okay. It's supposed to be brown. And the green one, y equals negative 2x plus 6. Everybody cool there? What do you notice? Y equals y equals. If y equals that and y equals that, then what do you know about these two? They're the same. So could I write it as negative 3x plus 7 equals negative 2x plus 6? Did I still eliminate a variable? I still eliminated the y. Does everybody see? This way is going to be your best friend in grade 11 and 12. Okay? The other two ways will work, but this way becomes much more useful. Now, what if, let's just for fun, I know it's not fun, but you know what I mean, you silly guys. Whatever, Bailey. Shut up. I can't even keep a straight face. Whatever. So we know this answer was 1 and negative 6, correct? Okay, so I'm going to erase all this. Now, watch. 2x minus 20 equals 3y, correct? So 2/3 x minus 20 over 3 equals y. Is everybody still cool? And down here, 2y equals negative 11x minus 1. Y equals negative 11 over 2 minus 1/2, correct? So y equals that and y equals that. So that means that 2/3 x minus 20/3 equals negative 11 over 2x minus 1/2, correct? Is everybody still with me? Okay. I just rearranged the equation so it equaled y. Everybody see what I've done? And I did the same thing here, but the x didn't show up. There. Is everybody okay? Now y equals this and y equals this. So that means this equals this. Is everyone still cool? Okay. Now, if I wanted to solve this for x, I don't like any of those fractions, right? So how would I get rid of divide by 3, divide by 3? Multiply this side by 3, right? And that would get me 2x minus 20 equals, and I got to multiply this side by 3, right? But I also got to multiply by what? 2. So what do I got to multiply this side by? 6.
Should you multiply both sides by 6?
I'm getting to that. Okay? So we're going to multiply this guy by 3 first to get negative 33 over 2x minus 3 over 2, correct? Now this side's got to multiply by 2. This side's got to multiply by 2, which is 4x minus 40 equals negative 33x minus 3. Right? Because all the 2's have canceled now, yeah? Now, Louis just gave me away. First thing I did was multiply by 3, then I multiplied by 2. So shouldn't I have just multiplied by 6 at the beginning? Now, 33 comes over here, right? 37x. 40 goes over there, 37. And I still get x equals 1. That's the point I'm trying to make. I've given you 5 new ways to solve systems. This way becomes very, very helpful when you are dealing with systems that look like this. Because now I could say this equals this. If this was bothersome to you, do you need it? No. You don't need it at all. Because all we did in the purple and the pink and the blue and the red here was, didn't we end up multiplying by 2 and 3 just like we did up here? It's the same thing. Okay, I just wanted you to see that further down the road, you can use this to help you out with more complicated ones. All right? All right. Now, you folks have page 239 and then another puzzle sheet. That's your work. Now remember, if you are going to use subtraction and it's subtracting a negative, what are you really doing? Adding. So if you're going to use subtraction, if you ever have the same sign and you want to subtract, you got to remember that, say it was that, it would be 3 minus minus 2, which would be what? 5x. Understand? That's a trap you might fall into. How can you avoid that trap? You do what Ash said, you multiply 1 by negative 1, or you do what Eric said and you divide 1 by negative 1, because they're going to get you to the same place. Does everybody get it? Try a few. You have the answers on page 239, but you won't need them because you can always double check. And then really try page 238, 240, because that has no answers. That's another puzzle sheet. Everybody good? Go. Yes.